Hello, so we're going to continue our lab over here from where we stopped it. I'm probably going to go over some of the stuff that we've talked about in the class, in the previous class, so feel free to, go over it or skip any one of them that you think we've already done in the past before. So here I'm going to just go over the example 005 will be here. I know we've already gone over that in the class before, so you should be able to see what we've got over here. Again, we're going to use our xdom. Now I've gone over how we use the xdom. You can use argument C and use V to display the content of what we have in here. And if you do that, you can actually pass it into head command. And that will allow us to see what we have as a header, of the file. And if you can take a look at this, but remember that this is a file signature for a zip file. So you should probably be able to know that. One of the things that you can also type over here is to use your unzip-t and type the exercise and go for 005.x, and if I do that, you can see unzip allows me to see that now I'm looking at XML format of Office document. This is not the OLE, the older format. Remember, we mentioned in the class that the previous format, which is OLE type of files, allows you to view use object link embedded type of format, whereas the newer format, starting from I believe Office 2007, uses XML format. There is a tools here that we can actually use that allows us to view the content of a zip file, zipdom.py, and I'll go over and to do this, and if you press enter here, you would be able to see the content of this particular file. You can see that they are mostly XML formatted file. One of the stuff here that you can also do is you can go over and look into the stream, of this file. By looking into the stream, you'll be able to see certain part of the stream that is of importance to you. Let's see that over here. And it's very, very simple to say it. You could also even go further by using the -A. Okay, that will allow you to essentially be able to dump and print out the content. So I can pipe this into head now to see the header information. Again, the -A allows me to see the ASCII, printout of this particular Word document. There are additional stuff I can also do. You can come over here and use -E, and if I use -E, it will allow me to see the extra information. You can see that. Allow you to see here. I'm looking at the bytes, the white space, the null, the ASCII, the X information, the magic number, and so on and so forth. And you can see all those information are printed right across the screen over here. It might be a little difficult for you to follow it, but pretty much you can print it out and you can see they are separated oftentimes by semicolon. So if you start from the beginning over here, you would see that the first thing you have at this end of this command is your index, and then if you look at the beginning of here, you can see that what you have is index. Then after the index, you have the file name, then it tells you have the file name, then you have the encrypted, and so on and so forth. You can see everything here separated by semicolon. If you look at the timestamp here you have the timestamp. See that? Semicolon, semicolon. And then after that, you have the MD5, and then here is the MD5 after MD5 you have file size, and then this tells you the file size. So another thing you could also do, I'm not going to do that here, is you can actually dump the content. And if you dump the content, that will allow you to be able to actually take a look at dump it right on the screen. It's going to do a standard dump, and you're going to see it on the screen. This might mess up your screen. You might have to open another window. That's why I didn't want to dump it. Also, you can actually try and run OLE dump against this and see if there's OLE dump files here. In this file, if you think there may be some the OLE file format over here, as you can see, there's none over here, and so there's nothing to be viewed. So this is very important for you to kind of like take a capture of and remember. So we're going to go over now to the next file that we have here in line, which is going to be the EX06 file format. And generally, if I just run my OLE type of files here, where's my OLE dump? As you will see now that I have a list of files now that are zipped. And one of the things we did earlier on for you, if you remember this time I typed this command here, that I can easily come over here and view the content of a file by just running them down through this. If I run it through, it's going to go too fast, but if I come back here, I can run them through head command, and by running through them through the command I can see, again when you see the PK, it tells you that it's a zip file. So the next thing I'm going to do here is to come back here and run the OLE files over here, and then we'll see this file that shows you have macro. And you could see that this, if you want to see the content of it, we can easily come back here and use -S 7 for the space here. Okay, remember the key important thing here, that the names here tells you have a micro VBA module 1, then this is macro VBA this document. Alright, so we can see it over here that these codes contain, let's take a look at this one here. You can take a look at it. One other stuff that you can also still do if you want to kind of just view it, you can go dash over here into dash V. And you can see here that these codes are attributes. They actually do not have any particular code contained in them. Another thing you can go ahead and take a look at is you can look at the second one, which is on the string number 8. And you can see that essentially these are just attributes of the code. They do not actually contain any particular Visual Basic code. So let's go ahead and take a look at actually let me go back here a little bit, and let's take a look at where we have here now. So we'll look at this one, but we're going to go ahead and look at the number 7 just to kind of view the content of what we have here. And here I'm going to just change this back. Change this to 7 and press enter, and right. Alright, so one of the things we've just seen over here is if you look at this particular file, there's a little bit of a difference between what we've had here and what we've looked at in the past, in the sense that this file has a capital M, uppercase M, letter M, and this one is lowercase m. It's very, very important for you to kind of quickly take a look at that. The reason that is important is for you to be able to see the difference between them. They look alike, but they are not actually alike. One of the things that you want to take a note of is the uppercase tells you the actual VB code, and the lowercase tells you the this is just an attribute of the VB code. We will take a look at the streams here and quickly look at what it is that we have here. I can go to 7. And I'll pop it into head. If I just want to see the code itself, I can simply just take a look at it, and I can see this is a subroutine that when the user open up this document, a hello world will be displayed on the message. You can look at the header of this information here. I can just pass this through into head here, and you can see here most of this is not a non-printable character, but here you could see the content of the message. It's very important for you to be able to see the difference between them. I'm going to go ahead and take a look at the next message here, the next file. That's number 8. I'm going to run them through the same process again, and here we have something similar to what we've had before. And again, let's pass document and go to 8 here. And if you look at this, the difference between this and this is here we're using auto open our command. This is kind of a Windows subroutine with a function, auto open function, which means when the user opens this document will automatically open without the user being prompt or anything at all. So you should be getting familiar with some of these functions now, whereas this is just a regular demo function. This thing would not automatically open or run the microcode. If you want to take a look at the other streams here, we can take a look at it, and you can see essentially it's just an attribute, whereas this one here is an actual code. Let's go ahead and take a look at 9 exercise here. As you can see here, we have something that looks a little bit similar. One of the things you're looking at here, let's take a look at the stream here, and we're going to be looking at 7, where we know we actually have the actual VB code. We can make it as V, so we could take a look at what is in there. Again, just in case you might be wondering, this what is all this? When you see this SRP _0 _1 and so on, that means this code had actually run before, and after the code was executed, the microcode, this file was saved. There's really no other more value to it at this point in terms of forensic, but one thing you want to note is if you see this, the difference between what you have here and what we have here is this code has not been run before the file was saved, whereas this code had actually been executed after that the file was saved. Another thing you should also see over here is when you look at these are just a simple files here, whereas when you look at it, this is a macros directory, and then you have a project inside a macros directory. Look at this one here. This is a macros directory. You have a VBA folder inside the macros directory, and then you have a file called module1 inside this file. So it's important to be somewhat familiar with that, especially when you are looking at some of the files. You can actually look at any of these files here. For example, I can check this stream and dump what is inside the stream. I can go to 10 over here, and if you, I'm gonna, I'll see, 1 second here, I think I pressed the wrong key here. Again, you can see the difference between this code and this code is simply because this one has been opened, and then the code executed, and then the file was saved, whereas this place, the code has not been executed before the file was saved. Just so something you want to take note of. It's very easy to kind of look at what is inside the code. For example, I can type -s over here and go to 10. Generally, what I will be doing if I wanted to do that would be essentially to go through part of what I have at the top of the code. You can easily run these by piping it into head. I ran this earlier on and my system doesn't like it for some reason. You can look at the content of this file here. So again, there is really not a big value to it forensically at this point. Alright, so we're going to move on to another file here on the list of what we have here, which is 10. And then let's take a look at what we have in 10 here. Essentially, what we have in 10 here is another code here, and then this is the attribute of the code. Let's take a quick look at what is in the stream. So -s, and I'm going to look for a 7 stream. I'm going to make it the rows. And over here, what I have here is auto open message, hello world. It looks as if we've seen this file before. If you remember, when we're talking about the auto open, it's very, very important to realize that there is certain things I want you guys to take note of. It is important for you to realize that this document is actually passworded with a password called infected, but because this code is able to read that without the password, you are not prompted. If you actually open this file in a Word document, you will be prompted for a password to view and actually to modify the code. Alright, so we're going to proceed to the next file here, 11. And one of the things we're going to look at is take a look at the content here. Go back here. Okay, it looks like this file is the same thing, but before we do that, we can look at a zip dump here. Make sure I have my zip dump file available here. Zip dump.py, yes, we have it here. So I've got my zip dump file here, and I'm going to take a look at this file. And if you look at this, you're going to see a series of files, but there's this particular binary files that you want to look at. It's a binary file, and sometimes you want to take additional extra look of this file, because it is possible to have a binary file, which is the older format of Office document, OLE file, embedded inside a Word document, an XML Word document. And when you do that, then you will run just like any other Office that is the OLE file. So this is what we're talking about. You can see this file over here, the binary file, which usually is an indication of the OLE file format embedded inside these XML file format. Another thing you should also take note of is when we run this, you notice that we don't have the number as the index here. You could see something is here. We have an alphabet and a number. Part of the things you want to notice here is that it is possible to have more than one OLE file format in an XML document. If we do that, then OLE dump will process it, but in this case, it's going to list A, for example, being the first OLE binary that is located. Let's say we have two OLE binary embedded inside this document. Then we'll have A, and then we'll have all the folders and all the files inside this binary, and then we'll have another one here that will be B, and then we'll have a B1, B2, B3, and so on and so forth. That is generally the way these will be processed. We can go ahead and examine the content of this string. Let's go for, and generally when I'm looking at this, unlike the other ones that we've done in the past before, how would I look at the content of this particular string? It's very, very important for you to kind of be able to take a look at it. I will simply just come over here and I will type A3-V, just like what we often done before, and I will dump it out. And again, you realize it's one of the subroutine that we found in the past before, so you're still pretty much familiar with it. The concept I wanted to learn over here is it is possible for us to have more than one OLE, even one OLE embedded in our document that is XML. So let's go on here and change this one to 12 here. And let's see, we are here. Right. So here we go. Here we have these, which is something you want to kind of remember whenever you have this. It means an arrow. It's got an arrow reading this OLE document, and I can go to -S and go to 7, and you can pipe it through here, and you can see potentially some of the information here, the runtime routine that is supposed to be here, the subtime routine. I can actually then go to type the same thing that I have earlier on, go to -V, and run something through here, and you're going to see it's going to say I've got error reading that particular segment that is it's got an error reading that. That's really what it means. However, there is an option that you could, just in case you have this in the future. OLE has a plugin that you could try and use. It doesn't always work. That might show you on how to decompress a corrupted video file. So if you were to run the same file, and in this case it's not going to work, because for some reason this file is actually corrupt beyond what OLE dump can fit. So I'm going to come over here and then come under this session here. I'm going to type --VBA, and I'm essentially copying this stuff here. here. Essentially copying this file, and I'm going to press enter, and you can still see that it still gives an error message saying it's unable to compress, in which case, like I told you, this is kind of almost a very hopeless case of a situation whereby a file is corrupt beyond something that we can repair. Alright, so we're going to go to the next file here now. Let's see what we have here. Okay, so we're going to take a look at it. Again, we have these two files here. And then the next thing we're going to try and do is run this file and just go ahead and look at our string here. Look at it. And then we can begin to take a look at it. And this is an example of a VB code that is intended to be a downloader. You can see here the attribute module 1, and then you can see a VB code or microcode that is declaring a function. This is a Windows API URL download to file, and what this essentially will do is to call this Windows API to go and get you can see declaration of string URL as a string and string path as a string, and then it's going to go ahead and get fetch this page, okay, and after that is going to download the file into the temp folder, and then it's going to append that to the index.txt, and then you can see set up the URL download to file string, and then specify what the path is going to be, and of course is going to execute. This is a very important code for you to understand. So it's very important for us to understand this subroutine. As you can see here, this individual is declaring string URL as a string, and also declaring string path also as a string. Then you can see the string URL providing a argument for it, which is the URL here, and usually this will be pointing to a bad guy's website, and then the path, that's the location where this file is going to be saved, is calling the environment variable and providing it with the argument of a variable of 10, and then adding, appending the name index.txt, which will allow this file to be saved in a temporary folder with this name index.txt. And then it's calling the API URL download profile and providing it with the name, the URL path, and also the path where the file is going to be saved. So this URL to the download profile will download the file by fetching the URL page and then saving the path to the path specified. And then another API, Windows API, which is shell execute, will open this particular file at this specified location, and you can see this another API here being referenced rather. So it's very important for you to see how generally the bad guys leverage these by calling Windows API, and you can query for any of these non-API to see if a code is doing something it's not supposed to do. Alright, so let's go on and do the last file of this segment of video, or second to the last file if you will call it that. Then what you have here, go ahead and do that, which is 7. 14 here, and this is very similar to the same file that we've just looked at in the previous example, except that in this case, however, you are looking at a different method of doing the same thing. Here they're using the ActiveX object method of leveraging a macro code to obtain a file from the internet, download a file, and potentially execute the file. You can see several variables were declared here. Declare str URL as a string, and this is to obtain the URL of any given URL. Str part as a string, which is a variable to specify the location. And then, this after we declared over here, we provide, the value or the strings to this particular string URL here that we declare up here. This will fetch this URL once we kind of apply it later, and then the string part over here allows us to specify our temporary folder in the environment variable, and of course we're appending this index.txt that will attach the name as the name of the file. And look here, if you look at this msxml2.xml http, this is where we are using the ActiveX over here to create an object, and we're using this http.open to declare a get command and supplying it with the string URL that's the URL of interest to us. And then we're also calling this XML http.send to then go ahead and fetch the page. You can see do while is introduced over here for us to more or less wait until this file is fully downloaded. And once this file is downloaded, it's going to get the result of this file and copy it in the area byte area of the memory. You can see this http.response body. That will be the file that we downloaded over here. The advantage of this thing is you are not depending on any Windows API to be able to download the file. As you can see over here, if you look at this code over here, don't forget this thing. This is the same thing as get command, and this is for us to open the URL, and this will wait until the file is completely downloaded. This is the response body, and we'll save the file in the area of bytes in the memory. And then you can see over here, this statement over here will essentially save the file on disk. This is a number to create a file, file numbers over here, and then it's going to open the path and save the file as a binary on the system, and this will assign the file number, the file in the area of bytes, and then this will close the file. So once the file is saved as a binary, we'll clean up the object, and then once we do that, we can go to the next phase here of this step. Here we create another object as shell application object. This object has a shell execute method, as you can see in the second line over here. And if you look at the method, we're going to pass to this shell execute object the part of the file that we saved, right up here, and then it would open it, which essentially is something as executing the file. So as you can see, this will essentially download the file, save the file as binary, execute the file. Very similar to what we have earlier before. There's additional plugins here that I would like to show you here. If you go over to OLE down here, this page, and gonna go over here to P to see all the plugins. You see here, I'm gonna Alright, so just show you this plugin over here. As you can see, we have this plugin HTTP heuristics.py, and one of the things I could show you here is how to use it. Then I'm going to run my OLE DOM over here, and one of the things that I'm going to do here is I'm going to leverage this file. I'm going to use my plugin for HTTP heuristic.py. And then one of the things I could do here is generally I will come over and specify the files I want to go after. I have these files here. I can go for my 14 files here, groups one. And when I do that, you can see this plugin here essentially pass through this file looking for reference to a URL, and essentially it's going to pass this out and say, I found something over here in the microcode that's trying to look for something, and if you find something that it doesn't really understand, it's going to actually print something that this is X format that might give me an actual indication of what might be going on within the system. Those are very, very valuable information that I think I would like for you guys to kind of go through and review them. Is very, very important. One other thing that I forgot to mention in my previous analysis, and I think let me see if I still have the file here. You can see here I use auto open, right? This is kind of like the subroutine. An auto open function normally will automatically run this code, but by using underscore, which is Stephen Didier actually wrote this code, by putting this underscore here, ensure that this code is not going to run automatically. Just something I think you should probably take note of. Alright, so this is going to be the last file I'm going to upload here for you guys to watch this week, and then going to be reflected in your final exam that I'm going to be giving you in the class next week. So we have another file here that we're analyzing. Again, as usual, it's got a macro code, and then we're going to run through it to kind of view what is in there. And this is quite interesting, as you will notice here quickly. This is the subroutine, as you can see. But unlike the previous one, which is a downloader, this is a dropper. It's another technique that is commonly used by the bad guys. Of course, the variables are declared over here, string part as strings, and the file number as an integer, string payload as a strings, and of course, old shell as an object. So the string part over here is, specify the location of where the file is located. And of course, look at this one. This is the interesting part, that our payload is given to us in base 64. So the string part here specifies the location of the file, where the file is going to be located, and of course the string payload is given to us here in base 64. The file number specifies the file number is going to open the part for the binary that is saved over here. Is going to put the file number into the payload. It's going to save it, the file number as a payload, and of course it's going to close it, and then it's going to claim the object, clear the object over here, and of course it's going to execute that payload over here. You can see this a little bit more if I want to go into a little bit more detailed analysis of these. I can go back into here and pass it into less, and if I do that, you might be able to see where the codes are declared a little bit more. Actually, go back here. You can begin to see a couple of declarations. One of the things I'm looking for is where we have, the environment specifier. 1 second here. Go back up here. sure you could see. You can see where we declare this is what we're looking at earlier. I'm going to go back up here. You can be able to see some of the stuff that are done over here to specify variable. So if we look at it over here, you can see the function that helps to decode it, base64. Takes it as strings, but then it's going to convert it into base64 a little bit later. So that's where it's going to interpret it. So if you go down over here and you look at what we have here, that's a very, very simple for us to identify. Again, it's important that you don't forget it. It's very simple. Write the IFI number as free file, open the path as binary, save it as a payload, and then close it, clean the object, and of course, when that is done, execute it. There's a number of ways to actually run these. You can go over here. If I want to convert to Python to base64, I'm going to have to import a couple of modules, which is binary to ASCII. Okay, so I want to import this. Import binary to ASCII, and then the next thing I want to do here is to then, after importing this module, I can go to binary to ASCII.A2B, which is ASCII to binary underscore base64. Then I have a quote here, then I can go over here and copy this file. If I want to copy the file, again, this is totally something I could do. Copy just this file here, and then go over here and paste the file, close parentheses over here, actually. So, and if I press enter here, and I can see that this is just hello world. Alright? But of course in real world it's going to be much more advanced than that. So this is going to be the end of this series of this video. There's a little bit less more for us to go, but I'll be posting that video a little bit later in the week. We'll be taking up the rest when we meet in the class next week. Thank you.